This is so fun. I mean, I'm enjoying it. I hope you are. Okay, so I'm just going to write, sorry for that. This is the preparation. And then here, the good thing about esters is there's only one way to prepare them, which is esterification. Okay, that's the only way. Okay, carboxylic acid, we had two ways. We are dealing with the normal one where we just oxidize, and then we saw how to come from toluene. Here for esters, our preparation is just going to be esterification. Okay, that's the only way to prepare esters. Esterification. Let's do it. Okay, let's do the esterification now. What do we have? Remember, it's just a carboxylic acid and an alcohol. Then you get an ester. So basic, it's very easy. So if you just want to put it CH3COOH plus, here we have a CH3OH, methanol. What are we going to have? Well, this, you can put it like this for our esterification, and you can put HCl and heat. Then what happens now? Well, what just happens is you are going to have H and OH come, and you're going to have a CH3COO, then CH3. How is that? And how do we name this? We start with this other side. This is the O we look at. This other side, which is not bonded to the double bond, is going to be the first. So since it's one, it's a meth. So it'll be a methyl. And then this other side, how many carbons do we see? 2. So it's methyl ethanoate. Oh, very easy, right? This is your ester. Now let's go to reactions. Now we want to do the reactions of esters now. We've seen the preparation. Now we want to do the reactions of esters. Reactions. How many do we have to know? Only 4. Only 4, and they are very nice, very interesting. Let's do the reactions. Let's start with the easy one, which we've talked about already, which is going to be reduction. Okay, reduction. Remember reduction, and we use LiAlH4 in ether. Now, remember the reduction, the things that we talked about when we talked about reduction. We have 5 things that can get reduced. What are they? Let me put them. We talked about how you have aldehydes and ketones. Okay, for aldehydes and ketones, we reduce, yes, we do reduction, but we use NaBH4 in ethanol, right? Then what about for these guys? For carboxylic acids and for esters and for amides, these 3 things are reduced. Yes, they are, using LiAlH4. Okay, in ether. Do not forget that. Okay, don't forget that. These are the guys that get reduced. So let's put esters. Is there in reduction? Of course, these ones, all these 4 lead to an alcohol, right? But for amides, it leads to amines. So this is what I should know. Okay, now let's do it. Let's do it. I mean, let's look at the reduction. This is so easy because if I have my ester, let's use this ester right here. Okay, CH3COOCH3, and we want to do reduction. So for reduction, we have to kind of like put it as a displayed formula. So you see, because reduction, we know that it converts. We can put it. It's going to be the double bond O is going to be converted to an OH. And then O and this thing will be taken away and replaced by an H. If this was an OH again, it would be taken away and replaced by an H. Like in carboxylic acids where you have C double bond O and this is an OH. We know that this goes and is replaced by an H. Then this becomes an OH. The same thing. This will become an OH. Then this goes and is replaced by an H. So we can say that we have CH3COOCH3. Then if we put LiAlH4 in ether, what are we going to get? We are going to just get CH3COH. Okay, CH3CHOH should do that. CH3, then this double bond becomes an OH, then here this becomes an H, and another H is added as well. So it's a CH2, because when this double bond O becomes an OH, and another H is then put as well on that same carbon. So that's why it's CH2, because here this will go and replace by an H. This double bond O becomes an OH and an H. So we'll end up having these 2 H's and an OH. So that is why we had a CH2OH, right? this is what happens. It's very easy. So if you were to put it, you could say it was something like this. Or, and then here we have a CH3. And we know this is a CH3. So what just happens is we reduce it, LiAlH4 in ether. This is the stronger one, okay? It is an ether. And what are we going to get? It is an ether. And what do we get? We are just going to get it as a CH3, then it's a CH3, then it's a COH, and here it's an H and an H, okay? H and H. Then plus, remember to also say plus. Oh, I had forgotten. This is going to be a CH3OH. So we should then do that. We should then put that other one plus, we just put, which is going to be like this, an OH and 3 hydrogens like that. Okay, because this O and it'll break here, right? And this O will go and become an OH somewhere, okay, CH3OH. Then this we know becomes an OH and an H somewhere. Then here we are going to have this go and put an H. So that's just what happens. And that is your reduction. Reduction converts double bond O to OH. Then everything else will go and be replaced by an H. To convert this to OH and an H, then this O goes and is replaced by an H. That is what happens in reduction. Is it the only one? No, it is not. Let's put the other things. Reaction number 2 of your esters. Okay? Reaction number 2 of your esters. Maybe I should stop here and I'll continue in the next one.